This video is designed to introduce you to the concept of constructions and to teach you how to perform some constructions involving line segments and line segment bisectors. Before we even get started, the first thing I want you to do is pause the video and take a few minutes to orient yourself with your compass. Draw some circles, draw big circles, draw little circles, draw all sorts of circles so that you know that you're comfortable and familiar working with your compass. So go ahead, pause the video now, and take a minute or so to draw some circles. Alright, so hopefully you and your compass have gotten acquainted a little bit and you're comfortable using it to draw circles, because that's what we're going to be doing. Alright, so first things first, what does it mean to do a construction? To construct a geometric figure means to create a specific design with some accuracy using only two instruments. The first instrument that we're going to use is the compass itself. And the compass is a device that's used to locate points at a given distance from a fixed point and to describe circles in their circular arcs. A straight edge is the second instrument that we're going to use, sometimes referred to a ruler, but is actually an unmarked ruler or just a flat bar that's simply used to draw straight lines by connecting two points together. Our first construction will be to construct a line segment that's congruent to a given line segment. So we want to create line segment AB in such a manner that line segment AB is congruent to the segment below. So we're going to start first of all by creating or drawing using our straight edge either a ray or a line segment that's a little bit longer than the given line segment is. I'm going to draw this one horizontally on my paper. I have on my given ray one endpoint already. What I need to do is I need to locate the second endpoint in such a way that the distance between the original two endpoints on the first line segment is the same as the distance between my two endpoints on my new line segment. Now, something important to remember when you're doing constructions is that your compass is always your measuring instrument. You are never going to measure using a ruler. You are simply going to use that ruler as it was intended, and that is a straight edge to create straight lines. Since I want to measure the distance between these two endpoints, and my compass is my measuring instrument, I'm going to go ahead and get my compass out. So now that I've got my compass out, I'm going to go ahead and I'm going to place the point of my compass on one of the endpoints of my line segment. And I'm going to stretch that compass out so that I can measure the distance between those two lines or endpoints. I need to stretch just a wee bit little further. And now that I know what the distance is, or I've measured the distance between those two endpoints, what I want to do is I want to come down to my new line segment. And I'm going to take the point of my compass, which was here at the point of my, or endpoint of my original line segment, and I'm going to move that point of my compass to the endpoint of my new line segment. I'm going to rotate my compass just a little bit. And finally, I'm going to go ahead and draw an arc. Now, as you're drawing arcs, you may find that it's much easier to rotate your paper than it is to try to turn or to rotate the compass. So anybody on that blue arc is the same distance away from that endpoint as these two endpoints were in the original segment. So my other endpoint for this line segment is going to be right there where the arc intersects the line segment. I need to label this segment AB because that's what I was requested to do. And at this point, I have successfully constructed a new line segment. Now, another thing with constructions is that it's important to leave your arc marks on your paper. So I need to see on your paper this blue arc which intersects the original line or line segment. So it's important not to erase those. That is how we grade your constructions. I'm not going to measure line segments or get a ruler out. I'm simply going to make sure that your arcs are the same here as they would have been over here on the original line segment. All right, so an important thing we learned from that, leave your arc marks on the paper, use your compass as your measuring tool. With that in mind, I'm going to go ahead and proceed on to the second one, which says construct a line segment CD that is twice the length of the given line segment. So again, the very first thing I'm going to do is I'm going to start with a ray on my paper. I want to now go ahead and measure the distance between these two endpoints. So I'm going to pull out my compass, my measuring tool or my measuring instrument. I'm going to place one end of my compass, or the pointy end of my compass, at one end of the line segment. And I'm going to go ahead and I'm going to stretch out that compass. So that the pencil is at the other end. And then keeping that exact same compass setting, I'm going to come down here to my new line segment. And I'm going to mark off an arc that's exactly that same distance. So if I were to stop right now where I've placed that blue arc, this line segment would be exactly equal to the original one. I want my new one to be twice that. So I'm going to come over here to where my arc intersected my line segment. I'm going to draw a second arc. We'll move that compass out of the way. And now the distance between those two endpoints is going to be exactly double what that guy was to begin with, making his length twice the length of the original. And since they said construct line segment CD, I'm going to go ahead and label its endpoints C and D. All right, moving on. The next construction is one of my favorites of all time. Given a line segment of length A, construct an equilateral triangle where A is the leg. So what we're trying to do is construct a triangle with three sides, all of equal length. We want them all to have length A. So again, I'm going to go ahead and I'm going to start with a ray. And I'm going to go ahead and begin by constructing or creating this horizontal line segment down at the bottom. So I'm going to go ahead and dig out my compass. I'm going to use my compass to measure the length of line segment A. I know that this left vertex is going to be that initial point that I have drawn on there. And in order to figure out where to put the vertex that's to the right on my triangle, I'm going to go ahead and draw that arc. Get my compass out of the way. So now this line segment has length A. In order to figure out where I should put this vertex, I want this guy to be exactly A units away from my original vertex also. So I'm going to go ahead and drag my compass back over there and put my compass back on that original vertex. And I'm going to take that arc that I drew and I'm going to extend it. I'm going to make it go bigger. Anybody on that circle is going to be A units away from the vertex on the left. Keeping my compass setting exactly the same, I'm going to spin my compass around, and I'm now going to go put the point of my compass at my red vertex, and I'm going to draw a second arc. Anybody on that arc is exactly A units away from the vertex on the right. So the spot where they intersect is going to be the point, the one and only point, that's exactly A units away from the vertex on the left, and A units away from that red vertex over on the right. So now each of these line segments each measure A units long, making that triangle equilateral. And they wanted us to label this DEF, so I'm going to follow directions and go label that triangle, triangle DEF. All right, that's a fun construction. It's also one that's very popular on the Regents exam, so I'm going to go ahead for number 4 and we're going to practice that one again. It says construct equilateral triangle XYZ using the given line segment as one side in the triangle. So I'm going to go ahead and dig out my compass. I'm going to measure the length of that line segment. I'm going to draw a nice big arc. If you want to draw the whole circle, feel free to draw the whole circle. Remember that as you're drawing these, many times it's much easier to spin the paper than it is to try to rotate the compass. So now I know that my second vertex should be right here. Keeping that same compass setting, I'm going to spin my compass around. I'm going to put the pointy part of my compass on that purple vertex. And I'm going to go ahead, oops, and I moved my compass, which I shouldn't have done. See if I can move it back. And I'm going to draw a second arc. So everybody on that green arc is now the same distance away from the purple dot as everybody on the red arc is away from that original endpoint. Now that I know where these two guys intersect, I'll go ahead and put my other two sides of my triangle in there. I'll get that compass out of the way. And now I can go ahead and label this triangle XYZ. All right, so there's the equilateral triangle. That one, again, a very popular one for New York State to ask about on the Regents exam. The isosceles triangle up at the top of the next page, we're going to save that for when you come back to class because I don't want the video to run too long. And I do want to spend some time talking about the perpendicular bisector, which is our second big construction for the day. So number 2, construct the perpendicular bisector of a given line segment. So in order to complete this construction, we're going to go ahead and get our compass out. And we're going to start by putting the pointy part of our compass on one of the endpoints of our line segment. Doesn't matter which endpoint, I'm going to go ahead and put it at endpoint E. And then we need to stretch out that compass so that the distance that the compass is open is more than 1/2 the distance of line segment EF. So something like that wouldn't work because our distance here isn't greater than half the length of segment EF. So I'm going to go ahead and open that nice and wide. Once I get that open wider than the length of 1/2, I'm going to go ahead and draw a couple of nice big arcs. And if it makes you feel comfortable, go ahead and draw the whole big circle. And again, remember, you may find it easier to spin the paper than it is to actually rotate the compass. I'm going to go ahead and flip that compass around. And now I'm going to keep the compass setting exactly the same, but I'm going to move the point of my compass to the other endpoint. So in my case, it's going to be endpoint F. And keeping that compass setting exactly the same, I'm going to draw another nice big circle. And again, if you want, you can draw the whole circles, but what we're really looking for in this case is we're looking for the point where those two arcs intersect each other. So I've got a point up here and a point down here. I'm going to use my straight edge to connect those 2 points. And this might be kind of hard for you to see because one of my points is actually not on my paper anymore. So I can slide that up. And that segment is actually the perpendicular bisector. So what I think is really cool is without a protractor or any other kind of measuring device, we've actually created a right angle. And we've divided that line segment into 2 equal or congruent line segments. All right, this is an important construction and one that you're going to need to know how to do. So let's flip up to the top of the next page where it says bisect each line segment below. I'll do the first one with you, and then you can do the rest on your own. So I'm going to go ahead and get my compass out, put the point of my compass at one end of my line segment, open that compass up until it's more than 1/2 the length of the original line segment. Go ahead and draw a nice big arc. Keeping that compass setting exactly the same, I'm going to spin my compass around and move the point of my compass to the other end point. Draw another nice big arc. If you want, you can draw the whole circle. and then use my straight edge to connect the points where those two arcs meet. And there is my perpendicular bisector. All right, at this point I'm going to have you go ahead and again pause the video so that you can practice bisecting the other 3 line segments on this page. All right, so now that you've got that construction down, I want to know how can you use this construction in order to identify or find the midpoint of a line segment. All right, so let's go do that now. Up at the top of the next page, it says use a construction to locate the midpoint of side AC. So I'm going to go ahead and construct the perpendicular bisector of side AC. Now side AC in that triangle has endpoints A and C. So those are the endpoints that I'm going to use when I go ahead and get my compass out. And I'm going to do that right now. I got to rotate this guy around a little bit. So I'm going to go put the point of my compass at point A. Stretch him out till he's greater than 1/2 the distance to C. Draw that nice big arc in there. And again, if you want, you can draw the whole circle. I'm going to spin him around now and move the point of the compass to point C. Change colors just because it's fun. Draw a second big arc, and again, if I want, I can draw a nice whole big circle. Now that I've got that done, I'm going to move my compass out of the way. Try to move my compass out of the way. Grab my straight edge and go ahead and connect the places where those arcs meet. So that represents the perpendicular bisector of side AC. So those two are equal. Because those two segments are equal, that's going to make that point right there the midpoint of segment AC. And I think they wanted us to label that with an M. All right, so that's really, I think, really cool because you've located the midpoint with no ruler, no measuring, nothing except a compass. The last thing that we're going to do is we're going to use our compass and our straight edge to find the circumcenter of that triangle. Remember that the circumcenter is the point where all 3 perpendicular bisectors of the sides of a triangle are going to meet. So what I'm going to do is I'm going to go ahead and I'm going to construct the perpendicular bisectors of all 3 sides of the triangle. This might get a little bit messy. So I'm going to go ahead and do the perpendicular bisector of the sides determined by those 2 red points first. And I am actually going to go ahead and color code to try to make this a little bit easier. So there's my perpendicular bisector of the left side of that triangle. Or I should say the perpendicular bisector will be in there as soon as I get my straight edge out and draw it in. I'm going to draw a nice big perpendicular bisector. I'm going to extend it a little bit. The next thing I'm going to do is I'm going to draw the perpendicular bisector of the right side of this triangle. So the segment determined by those 2 purple dots. Let me grab my compass. I'll spin this guy around and go put his point at the other end point. And again, I'm going to go ahead and move that compass out of the way. And I'm going to be a little bit smart. I know that the perpendicular bisectors of my triangle are concurrent. That is, I know that all three of them meet at one point. So if I were to construct the perpendicular bisector of this third side, it would meet at the same point where the other two meet. And in the interest of time, I'm going to go ahead and put a stop on that right now and label him the circumcenter. And there's one other really cool thing about this that I want to show you, but in the interest of time, because I'm now running it a little bit over 20 minutes, I think we're going to call it a day for this video. The next time that you come back to class, you want to make sure that you bring your compass so that you can have it and work with it and get comfortable using it and seeing how it works. And we'll do some practice with some of these constructions.